Okay, class, let's talk about how we're going to solve this week's nonlinear equations. So I made up a problem here where we're going to have some nonlinear equations and we're going to solve these. Now, the process we use this week should look an awful lot like what we did last week. It's just going to be a little more complicated equations. So for my example, let's assume we have an inductor where the voltage is proportional to the derivative of the current. If the current has this form, which looks a lot like a problem we worked in class this week, when we take the derivative of that voltage, of that current, to find the voltage, our voltage is 4.8 e to the minus 5t times this 3t squared minus 5t cubed. Now, let's see if we can figure out what the power is going to be, where the power is the voltage times the current. So I'll have to take this equation for current, multiply it times that equation by voltage, and we'll have the power. And we're interested in finding out the exact times when the power is equal to 0.01 watts. So we're going to do that in Matlab. All right, let's go look at Matlab a bit. First of all, I want to plot that equation, so I'm going to do a simple plot. There's my current equation right there, 24t cubed e to the minus 5t, multiplied by, and here's my equation for the voltage, 4.8 e to the minus 5t times 3t squared minus 5t cubed. And let's look at this for, I don't really know what sort of time is going to work, so let's look at it for 50 seconds and see what we get. All right. When I look at that graph, okay, I'm seeing that all the excitement happens in less than 5 seconds. So let's redo that plot and keep it at less than 5 seconds. Oh, there it is. Let's go, whoop, wrong one. Let's go to 5 seconds here. All right, making that 5 seconds. What's my plot going to look like now? Oh, all right, I'm seeing some more action. Now I can tell it looks like everything exciting happens before 2 seconds. So let's try this one more time and just take it from 0 to 2 seconds. Come in here and change this to a 2, plotting the first 2 seconds of this graph. What do we get? Aha! All right, so my graph is going to look like this for the first 2 seconds. Looks like we get up to like 25 milliwatts and down to 15 milliwatts, something like that. All right, so my problem asked me to find the times when it was equal to 0.01, and it looks like that's going to be at around 0.2 seconds and somewhere around 0.6 or 0.5 seconds, somewhere in that neighborhood. So those are the times I'm going to investigate. All right, let's get rid of this, and what I need to do now, I'm going to pull up my script that I wrote. I hit it somewhere on one of my screens. There's the trick. Ah, there it is. There we go. Here's my script. All right, so there's my plot. I just copied the little plot graph that I just used. Now, I turned on the grid and put some labels on there so I know what's going on. I want the power equal to 0.01. So I'm going to take that equation, subtract 0.01 from it, and then I'm going to find the zeros of that. So here's my anonymous function equation again. I just copied the stuff from up here down here, and then I'm going to find the zeros of that. And we expect one around 0.2 and one around 0.6. Let's see what happens when we run it. Click the run button. There's our graph. That looks familiar. What sort of roots did we get? Hey, we have one at time of 0.2 and one at time of 0.5173. All right, so that looks good. So it appears that our little script works. Let me suggest to you where you're going to make mistakes is where you're typing in this equation. It's really difficult to get all of that in there without making a mistake, having the wrong number of brackets at some spot, or forgetting a minus sign, or sticking a wrong number in there. So anyway, be very careful when you type in this equation for the plot and the same equation down here for your function. But other than that, it should be the same as we did last week. Have fun.